Okay, so let's move on to next one, the determinants. Determinants are also kind of related with the matrices. Determinants and the matrices, these are the tools in a linear algebra that we use to solve the equations and get their solutions, right? So determinants is also a tool which is related to the matrices, right? So it's, you can think of it as a scalar value or some number for the matrix. Let's say we have a matrix A, 2, 1, 3, 2, right? Like this. And we want to find the determinant of A. It's written as determinant, and then you can write it like this, or the other way to write it is you can put A and then put the line around it. Yeah. So we want to find this determinant. Okay. So this is a 2 cross 2 matrix, or yeah, this was a 2 cross 2 matrix. So we are doing its determinant. Okay. So for its, this rule is only for 2 cross 2 ones. You multiply this one with this, 2 times 2, and then you put the minus sign, this minus sign here in the formula, and then this times this, and then 3 times 1. So 2 times 2 is 4, minus 3, that will be equals to 1. So the determinant of the matrix A is 1, right? And there is another thing about the determinants, that we can only do the determinants of square matrices. All right, let's say if someone gave you matrix like this and ask you to find its determinant, okay, and there says like find the determinant for this one, you cannot do this. Why? Because this is a 1 cross 2. It's not a square matrix. The number of rows and the number of columns, they are not equal. So you cannot find the determinant of this one. Right? So you can only find the determinant of the square matrices. And as we go to the next step, like 3 by 3 matrix or 4 by 4 matrix, matrix can be of any dimension, 5 by 5, 6 by 6. It gets difficult to find the determinant. So the general, let me write the general rule. Let's look at the general rule for finding it. So the general rule is, let's say I want to find the determinant of matrix A. All right, it is minus 1 I plus j, where I and the j are the number of are the entry for the row and the column. Okay. Oh, wait, sorry. It's the sum. That's the sum for, we do all the okay, so we do the sum of all the entries, for that. Okay, so the i's are the row, like it starts from 1, right, and it goes up to like the end. All right, how many, the n is like how many rows are in it, right, or columns. So like that. So and then I plus j, a I j, and m. Let me tell you what is aij and mij. So aij is the entry, right, like a11, a12, a13, like that. Yeah, let's say this is a11. This is ij, means a12, a13, this is a21, right, a22, like that. So the aij are the entry for that place. Okay, and mij, the one that is written as mij, that is called minor. Minor of whatever, of minor of a. Okay, and then ij, whatever the identity is. Okay, so like whatever entry. So let's say I have a matrix 3 by 3. Let's try to do it with an example, right? So let's say I have 1, 3, 2, 4, 1, 7, 2, 5. Okay. Okay, I want to find M1, 2. Okay. Minor of identity 1. I want to find M1, 2. So what you do, you go at this place in the entry. Where's this entry? First row, second column. This is it. Okay. So what you do, you ignore this column and you ignore this row. You ignore the column and you ignore the row, all right? And you write, and the remaining, you just write the remaining. So what's left over here? Let's do the determinant for the remaining. So what's left? 4, 7, 4, 7, 2. All right. So like then you find the determinant of this thing. This is M1, 2. Let's say I want to find M3, 3. Okay. It will be, we will ignore the third row and third column. So we will ignore the third row and third column like this. We will ignore that and write the remaining. And then we find the determinant of this one. Okay, like 2 by 2 that we learned before. So this is the minor. So it can be for 3 by 3, it can be for 4 by 4 matrix. We can still do this. Okay, so and there is, if we have a 3 by 3, so let's say we take a 3 by 3. Okay. Just a matrix. First of all, 1, 5, 3, 2, 7, 2, 3, 0. All right, like that. We have something like this. Let's say we want to find its determinant, right? So what we need to do, we need to start from first entry, all right? We need to complete how many columns we have, all right? We can do that way. So first of all, let's start from here. So first entry is, first of all, we write -1, its power I plus j. So what is the entry for this 1, 1? It's 1 plus 1, right? And then aij, that is the first entry. This is the number. Okay, so this is, let me write I plus j. I'm writing the formula down so you can see aij, and then the thing. Okay, so now mij means the determinant of the thing, right? So what is the determinant? Like, okay, so mij will be this much, right? Ignoring the first row and the first column, like that. Okay, then we get to the next. We need to add all of them until, like, you start moving from there until the number of the number of columns end. Okay, so next one is -1, and then I is still 1, first row, second column. Okay, the entry is 5, and then time, this ignoring this row and this column, we get we ignore that, and left over is 2, 3, 2, 2. So just zoom out a little bit. All right, so like that. And then again, we get to the next row, oh sorry, next column, next entry. That is now this 3, 3. So now -1 power 1 plus 3. Oh, sorry, yes. So it's third column, first row. So 1 plus 3. And entry, here comes the entry here. And the entry is 3. And then times it by ignoring this row, this column. That will give us 2370. Now we just saw, now we know how to solve a 2 by 2 determinant. Yeah, this times this minus this times this. And -1 to the power 1 plus 1 will be 2. -1 to the power 2. And then this is 1 times 7 times 2 minus 0 times 2. Okay, so now we have -1 to the power 3. And then 5. And then you multiply this 2 times 2 minus 3 times 2. And then again next one. Okay, now it will be -1 to the power 4, 3, and then 3 times 0 minus 3 times 7. Okay. So now we can see, okay, so -1 to the power of even powers will make it positive. So it will be 1. 1 times 1 is just 1. And 1 times 14, because 7 times 2 is 14. 14 minus 0 is 14. Then plus, so, okay, so -1, its power is minus. Its power is odd. Okay, its power is -1 to the power odd. That is 3 power. So it will give us a minus. Okay, -1 times 5 times 2 cross 2 is 4. 4 minus 6. That is -2. 4 minus 6 is -2. And then plus, okay, so -1 to the power 4, that's a positive power, even power. So that will make it 1 as positive. Okay, so it's just 1. And then 3 times 0 is 0, minus 3 times 7 is 21. So -21. You now just add them. So 14 and minus times minus is positive. That will be plus 10. And plus positive times minus is negative. So 3 times 21 is minus 63. So then all we left with is to add them. So let's add them. So 24 minus 63. So that will be minus 39. So that's the determinant. The determinant of the matrix A that we had up there is, just zooming out. So this matrix A, the determinant of this matrix A that we had is minus 39. And just one more thing, and there is many other things, but let's just tell one more thing and then we move on to next. Okay, so if, but it, like, so there is some determinant there, like that matrices whose determinant is 0. Okay, so when determinant of A, of matrix A, is 0, okay, then that matrix is called singular matrix. Singular matrix, right? Similarly, the idea that we had used here, we can extend it to 4 by 4, 5 by 5, right? Let's say when we were doing this and we get a matrix that whose determinant the M. Now here we got an M whose value is 2, 2 cross 2 matrix. But if the original one is a 4 cross 4 here, this one is 3 cross 3, but not. So if we have 4 cross 4, then we will get 4 3 cross 3 matrices for the determinant of, then we will have to solve 4 determinants of 3 by 3 to get the answer for a 4 by 4 determinant. So that's a lot more complicated and will take a lot of time. So all right. Is okay. If anyone have question that you can ask, okay, and then let me see if we can. Okay, there is some other some basic rules that are we can see. There is some other basic rules that we can see is, let's say we can multiply, let's say there is a matrix A, all right? We can multiply it with a scalar number. Let's say like we can multiply it with a scalar number. So let's say we do it, we multiply it with a scalar, multiply with 2. Okay, so then it will become 2A, all right, like that. So let's say our, like say 2, and then I write an A, just any example, let's say identity matrix, okay? Just for the example, all right? So how we multiply this times this, they get multiplied with every entry. The 2, it gets multiplied with every entry. 2 times 1, 2 times 0, 2 times 0, 2 times 1. So this 2 gets multiplied inside with every entry. So it's 2, 0, 0, like that. All right. So this is 2 times A. Similarly, you can do 3 times A or any number times A. And let's say we want to find the determinant. All right. So the rule is for the determinant, let's say whatever, let's say we want to find the determinant of 2A, right? Which is equals to 2 times the determinant of A. All right, let me just show you. So what is the determinant of this one quickly? If I see this is 1 times 1 minus 0 for this one, right? So 2 times, and the determinant of this thing, which is 1 times 1 minus 0 times 0. And which is 2 times 1, which is just 2, right? Now let's redo the determinant of this 2A, right? This thing, this 2A. Now let's do the determinant of this one. That will be 2 times, oh wait. No, there is a, wait a second. It's not. It should be the same. Wait, let's see where's the. Oh, that will be 4. Yes, okay, that's right. That's correct. That's correct. Okay, so oh, okay, no, sorry. I think I made a mistake there. Sorry about that. No, I think I made a mistake. It should be like, okay, so like that's right. There's a mistake word. Sorry. So no, this one doesn't work. Okay, sorry. There, I think I made some mistake. All right, so like this is, we can multiply the matrices with like that. All right, so 2 times A, 3 times A, 5 times A, we can multiply the matrices. All right, so now let's just quickly move on to the last thing, probability. Oh, sorry. Probabilities.